I work with lots of different clients and different companies, helping them solve their signal integrity and power integrity problems. There was a lot of people in the management who are aware of these issues, signal and power integrity, and they're sort of struggling to figure out how they can keep their teams involved and up to date with the latest tools and the latest methodologies to get the product out the door. So some of the challenges that I see that design teams are facing are that they're trying to reduce their bill of materials, and they're also trying to optimize their designs for performance. So a lot of clients are putting a product out to market for the first time, so they want to utilize signal and power integrity analysis to make sure that it's going to work to market the first time out. So for power integrity, I think a lot of designers are really starting to face the issue for the first time in terms of you have your die, your package, and your board, and how are you going to roll that into one complete power solution? So it's not just a matter of reducing your coupling capacitors on your PCB anymore. You got to worry about what's happening at the package and die level. What's the inductance of your flip chip or your wire bond design, and how is that working with your I/O in terms of getting the clean power out? And we can sort of tie that back even to SerDes design, where even just a little bit of power noise is really going to hurt your jitter performance. So you really need to make sure you've got clean power. And I think a lot of designers are really starting to understand the impact of that and really start to look at those power design issues today. So a best practice I would recommend for design teams in terms of signal integrity is to really try and follow a flow where you do most of your work up front in a pre-layout phase. So while your board designer is placing parts and your routing guy is starting to do the breakouts, is to have someone doing the signal integrity along with that so you can make informed decisions to make the best design. And things you can think about is, crosstalk. How can you minimize crosstalk in terms of what your trace spacings and trace lengths and things like that should be? And I think if you do that, then you're going to have a much better design at the end of the day. Another piece to that is doing something like a post layout analysis. So once you have your board done, you've done a lot of work up front, before you ship it out the door, you do some quick sanity checks. You look at some of your critical nets. Make sure that the routing rules and all the work you've done up front has actually been followed through on. This way you don't spend all your time up front, miss something, and then you get in the lab and you have to debug it. So if you sort of break your work down into that type of flow, it will really help you solve a lot of your signal integrity problems. For the PCB design challenges in power integrity, I think a lot of designers are really starting to look at optimizing it. And there's a lot of different methodologies and tools out there that help you figure out, well, I've got this board, and how do I figure out to put the right amount of decoupling capacitors on the board in the right places so that I have clean power, but I'm not over-designing it. I think a lot of people are trying to optimize in terms of cost, and I think that's really one of the driving factors for a lot of PCB designers today. Signal integrity can be used in different avenues to solve your design challenges and meet your business goals. So I see a lot of clients are trying to use signal integrity to make their product work the first time out the door, to reduce their time debugging in the lab. Another thing is a lot of companies are using signal and power integrity to reduce their costs. So for example, they want to reduce the number of decaps on board, they want to reduce their layer count in their PCBs. So they're using a lot of signal integrity analysis to sort of reduce their costs while still making a good product that they can get out the door on time.